This video was made in partnership with Texas Instruments.
I'm here now with Errol, and we're talking about electrification technology for our homes. And Errol, what's your role at Texas Instruments?
Hi, pleasure to be here at CES. So my role is actually the systems and marketing manager for EV charging and smart meter applications within the grid.
So cool, within the grid. And that's such an important part of our electrification landscape, right? Is that home to grid connection and home to EV connection. Can you describe a little bit about what we're seeing behind us here?
So as you can see here, the way we have it is from the grid all the way to where you would have some sort of power or some sort of load. So in this case, we have an example of going from the grid to your meter to pretty much throughout the areas of conversion, from high voltage conversion. This is where you have like your hybrid inverter, where you might have, for example, like solar as like a source, or grid. How do you manage those different things efficient and effectively? And then how do you store that energy? So this is where we have like different solutions that we're showing within energy storage. And then for powering, we have an example here of like an EV charger, right? Being able to charge like your electric vehicle.
And what excites you the most about this technology?
What excites me the most about it is just the impact actually it will have, like, on the environment, right? And what we can do with semiconductors here to not only, help with making things more efficient, more reliable, and having more of like a seamless sort of experience here. So I think the most exciting part is the innovation that we do with our products to help customers to innovate even more and make this transition happen even faster.
Right, we need it to happen fast to reach those goals of, lower carbon emissions worldwide. So this is an important part of that technology.
Exactly. And I think one of the great things about this too is just how you can disperse that energy, right? So utilizing it, for example, in case of emergency, if the power goes out, then being able to use either your energy storage system or even your car, where we're seeing those standards come, like, new standards for being able to do that bidirectional power transfer.
Yeah, I'm so glad you mentioned that. I'm super interested by bidirectional charging we have with electric vehicles coming up. And is that what this system can do that's right behind us?
Yes, exactly. So we have different bidirectional topologies, for example, with like the string inverter, where you can utilize that for exactly that, connecting either like your energy storage, converting that to a particular sort of voltage, or going back to an inverter to AC back to the grid, or even converting like your solar power to AC back to the grid. So a lot of our designs, we have both like unidirectional as well as bidirectional topologies, both with silicon carbide sort of examples for reference designs, as well as GaN based. As you can see behind, this one actually is a GaN based design.
Gallium nitride. That's pretty cool. Do you have any of this technology at home?
I do have an energy storage system.
I am so jealous. Like, we have solar and we have electric vehicles, but we're missing the energy storage, and that would really help with our cost of our electricity, and also just it's more efficient, right?
Right. Exactly. And I think you're going to see this even more and more as you have this. And I see this as far as a future trend is how do you manage those effectively between the different timing. So for example, when would you use your solar versus the grid? When would you use the grid versus solar? Or when would you use your energy storage system versus the other two? Yeah,
and it's would you optimize for cost or for energy efficiency? Is there a trade-off there?
I would say it's a good question. That's where I would say it's more of the energy providers for that. I would say from an efficiency perspective, we try to get the maximum efficiency with our devices, right, and demonstrating that with topologies, right, whether that's designs like we have with T-type inverters or even ANPCs. But for cost, right, I mean, that's going to depend on your service provider at that point, right?
Yeah, they're ultimately the ones who control our destiny when it comes to energy costs.
Exactly.
Thank you so much for your time. It was such a joy to talk to you about this awesome technology here.
No problem. No, pleasure.